Hello everyone, welcome to All Hand ESCO meeting. My name is Ichichku Grace Aore and I'm from the Shaw Group. Today we'll be talking about scanning electron microscope with energy dispersive spectroscopy. What is scanning electron microscope? Scanning electron microscope is also known as SEM, is a surface microscope that uses beam of electrons to form an image, to create an image. Unlike the optical microscope that uses light to create an image, this SEM is preferably because it has a resolution limit of approximately 0.2 nanometers. And it's very good for surface imaging, surface characterization. It gives us good information about physical morphology of a sample and also the chemical composition using EDS. How does the SEM work? The basic principle of SEM is first the electron gun generates beams of electron that pass through a series of lens and through the series of lens until it gets to the sample. So what happens is this beam goes through the anode and through the condenser, and the condenser helps to converge this beam, and then it goes through the scanning cord, which helps to raster the beam onto the sample, and then through the objective lens, which focuses the beam onto the sample. So at the end, these lenses help to focus the beam onto the sample. And then when it gets to the sample, it's detected using 3 different detectors: the secondary electron detector, the backscattered electron detector, and the energy dispersive, the X-ray detector. So for the backscattered and the secondary, so the backscattered backscattered detector, what happens is that when the beam hit the sample, then it reflects back after an elastic interaction between the beam and the sample. But then for the secondary electron, the beam also hits the sample, and then the inelastic interaction between the beam and the sample hits back, and it's being detected using the secondary electron detector. While the X-ray detector is as a result of it knocking out electrons from the sample. So this is what the picture to show these different detectors. You can see the incoming electron beam, the yellow, hitting the sample, and then the secondary electron detector is like the very surface. The backscattered electron is a bit deeper, and the X-ray it's really deep, and that helps us to know what the chemical composition of the sample is. How does the EDS work? EDS is a technique that is used to identify the elemental composition of a sample. So what happens is the incident beam ejects an electron from an inner shell, and then a shell and then it creates a hole because it gets ejected, and then it creates a hole when the electron from the higher energy shell is going to go down and replace and fill in that hole. And so the difference between the higher energy shell and the lower energy shell is being released in form of X-ray, and that is detected using the EDS, that is measured using the EDS. So when you look at this picture over here, the K shell gets ejected, and then it creates a hole, and then the higher energy shell which is the L shell goes down and replaces the hole, and then the difference get emitted as the X-ray emission. And then also when you look at this one here, the L shell gets ejected and then it creates a hole, and the L shell and the M shell from the higher energy shell goes down and replaces it and fills in the hole, and then the difference get emitted as the L X-ray emission. So for sample preparation, the SEM has a vacuum where we put in our sample, and it has a stage. So you put your sample. Another thing we should note is that we use just solid materials for SEM. So you put your sample on a tape on the sample plates, and then you measure it and be sure that you know what the measurement is. Then you put that into the system and place your sample plate on the sample stage, and that helps to move the stage up to the position where you have set it. And it's important you do this when the vacuum is still open, because if you set the stage and don't allow it to adjust before you close the vacuum, then it could go up so high and crash the detector. So it's very important you do this when the chamber is open, and be sure that you have the stage set well before you close the chamber, and then you can start analyzing your samples. So these are some of the SEM images that we collected in our facility in the University of Iowa here. By my right is an SEM image. It will show you what time you collected it and what measurements you used in collecting the image. And then like the voltage and the currents. And then this is EDS mapping that shows the elements that are present on the image, on the sample. And this is also a very good image showing the EDS mapping on a sample to show the elements that are present on the sample. So you can see here, this is what the SEM image looks like, and then this is the EDS mapping. So it's showing us that there's presence of oxygen. We can see this over here. This is oxygen, and we can see carbon. It's showing that there's presence of carbon. There's presence of phosphorus. There's presence of sodium. So it just helps us to map and show us the elements that are present in the sample. So this is also another another thing we can also do with using the EDS. So we can see what the mass, we can see the elements that are present, we can see the mass, we can see the atom. And then from the peaks also, we can also analyze it. So this is another example showing EDS mapping with elements that are present. And this is another way we also do this. You can draw a line, and then it will just look at that line and give you the elements that are present just around that area where you drew the line. And also it's similar to this. You just draw a line, and then you'll be able to see the elements that are present around the area that you drew the line. And also, this is another way we map. So we can put a circle on a particular spot that you want to know what is present, and it will give you spectrum showing the different elements that are present around that area that you're trying to map. Thank you so much for listening. I believe you learned something about SEM EDS today. Thank you.